Welcome back. In this tutorial, I'll explain to you about the results of the Kaplan Meier analysis based on separation of the patients according to whether they have a mutation in a driver gene or not, and another separation by expression in a candidate gene. Okay, so let's run. Let's choose breast cancer and our driver gene is met. Do we want to output images? Let's choose all of them for now. Output directory, test, okay. Or you know what? Let's see, test. Yeah, let's do in test 2. And we will choose Kaplan Meier by mutation and expression. Done. Again, code is running. The process of Excel was terminated. Now, here's something that I want to show you. The thing is that there are not many documented, or there aren't many mutations in genes, or if there are, they are not in the genes that we want to check. Okay, so what happened here is that we try to split the cohort, or we try to split the patients by the driver gene met, and the problem is that there are no mutations in MET, specifically in the breast cancer data set. So let's say that you do need this type of calculation, you will have to find another data set. And it usually happens with MET. You will be luckier with TP53 and maybe with BRCA1 in breast cancer. Okay, so let's do that again, but this time let's do that with when BRCA is the driver gene. So we'll choose breast cancer again, upload file. Okay, our driver gene this time is BRCA1. Output images. Let's output. I've already outputted the images, so beforehand. So this time I will not print any images. Output directory. Let's say test2. Select folder. Second step, and Kaplan Meier by mutation and expression, and we will click done. The code is running. We're waiting just to see that it is able to run. Ah, okay, and the code is running and it is doing Kaplan Meier analysis. So now I'll explain what you get. So you will expect to get 4 Excel files and Excel tables. And here you see Kaplan Meier, candidate genes versus mutated. And the mutation is in BRCA1. This time, BRCA1 is our driver gene. And the gene 2 was split according to high expression in the candidate gene. 20%, we take 20% patients with high expression in the candidate gene, which is denoted by G2, and the rest of the patients. Here it is split by high 30, R70, R70, low 30, R80, low 20. Usually you will only need to look at these two files, high 20, low 20. Okay, and let's look at the graphs that we get. And done. So we can actually look at our Excel table. And it is very similar to the table that you have seen in the Kaplan Meier analysis by expression and co-expression. Okay, page layout. Again, this is the place where the data was taken from. Our main gene or driver gene, this time it was BRCA1, just for, teaching purposes. If your driver gene is met and you don't get a mutation you don't have any patient with a mutation in MET, then that sucks. And you don't have any results. And one of the reasons why I don't split or do any Kaplan Meier analysis by mutation in the candidate gene and not in the driver gene is because it's very hard to find such mutation. There is simply not enough data. So we combined here mutation in driver gene and a separation by expression in the candidate gene. So here is our candidate gene, and this is our candidate gene. The candidate gene was split by high percentage 20 and the rest 80. Initial number of patients that had a mutation in BRCA1 and also had a high expression in 2xAB or candidate gene in this case. The initial number if with mutation in BRCA1 and low expression, or the rest of the expression in the candidate gene, in this case 2xB. Initial number of not mutated and high expression, not mutated and low expression. And again, we take p-value according to log rank test for multiple groups. And in this case, we are we say we try to find where the significance was, whether the p-value was significant, whether it was lower than 0.05, and let's check for the graphs. Let's look at graphs, and okay, let's look at a graph, for example. So here you see that a Kaplan Meier analysis of gene 1 is BRCA1, which was, and we split the patients by whether they had a mutation or not in BRCA1. And they had a mutation in the blue group, they had a mutation in the red group, they did not have mutation in the yellow and purple group. And we also split by the expression of G2, which is the candidate gene. In this case, it's ARF3, and it was split by high expression 20% and the rest. So the group which had mutation and a high expression in ARF3 is denoted in blue, and the p-value was 0.4. It is not significant. So let's look at something that is significant. It was tuba, right? Tuba, RST tuba AB. And we will take, and we looked at high. Okay. So here's something a little bit different that I would be a little bit careful. So this is a result when we split by a mutation in BRCA1 and tuba AB, A1B, sorry. And the p-value was significant, but you can certainly see that if you take the group with that had a mutation in BRCA1 and had a high expression in tuba A1B, then yeah, that group's survivability was worse. They get a worse prognosis. But if they also had a high expression in tuba AB and they didn't have a mutation in BRCA1, which is the yellow group, their prognosis was also not that good. So we see here a certain split by tuba A1B, and not just, you know, we would want to see the blue group significantly worse than the other groups. And yeah, so you will have to look at the graphs that you get. So another thing I want to comment on is that okay, first thing is that I changed this column to indicate that the p-value is significant, not in comparison to the driver gene as I previously showed you. So that's something that I fixed in my code. It's not that important. The significance is taken according to whether the p-value is lower than 0.005. Okay, another thing is I want you to notice that the groups here, the initial number of the patients in each group are not that I don't know, not all of them are statistically significant. If you see in this column where the patients had a mutation in BRCA1 and they had a high expression value in the candidate gene, then the initial number of the patients here was 9. And there are cases where the initial number can be much lower, and what it causes is that for the calculation to not be statistically significant, but if you have a group of 2 or less patients, then I simply don't output the result at all. And this is with BRCA1. It's a little bit better with TP53 because it's a tumor suppressor in cancer. But again, in this case, we had fewer patients in general. Yeah. But just so you know, you don't have many patients, and don't be surprised that you don't get results for certain genes. All right, goodbye for now.